thought I told you. What's up? How you doing, brother Cecil, man? So, you know, we have to solve integration by parts. So when they give a question, they don't want to tell you this is integration by parts. You know what I'm saying? They just give a question, say, oh, you gotta solve the question. So now it's up to you to identify whether it's integration by parts or not. So just by looking this, of course, yes. You know why? Because you have integral and then you have a trig inverse. Whenever you have an integral and then trig inverse, that's integration by parts. So now let's see how we can solve this. You know what I mean? So now, first and foremost, we're going to write a formula. So we're going to write a formula. Like I said, it's integration by parts, but it has an inverse of trigonometric equation. So now, first and foremost, let's write a formula. So we're going to write a formula first. Okay, so our formula, solution. So we're going to start a solution for the first one. So we're going to write a formula, integral u dv equal to u v minus integral u dv, so this is going to be v du. Okay, so this is going to be u and this is going to be dv. So say let u equal to the first one, which is sine inverse of 2x, and dv equal to dx. So what we're gonna do here, you know, we're gonna differentiate this one and then we're gonna integrate the second one. You know what I'm saying? So now let's differentiate this one. So I'm gonna differentiate here. So first and foremost, if somebody give you, whenever you give him differentiate sine of a function, sine, or a sine inverse or arcsine. When you say arcsine, sine inverse is the same thing, of our 2x. So differentiating this one is easy. So what you do, according to the formula, differentiate what you have here. When you differentiate 2x, you're going to get 2, because this is power 1, 1 comes back, it's going to be 2, and then it's going to be x, 1 minus 1 equal to 0. So it's like 2x power 0, which is equal to n number 0 equal to 2. And then you put under root, this is a rule, okay? You under root for sine, okay? You say 1, okay? 1, and then you minus, okay? And then take exactly what it is here and then you square. So you're going to say 2x. Then what you do, we square. So this is going to give us 2. 1 minus 4x squared. But we have what? We have a square. So if I differentiate everything here, means when you differentiate u, it's going to give it du. And when you differentiate everything here, it's going to give it 2. And the square root of 1 minus 4. X squared. You know what I'm saying? So now we go for the right hand side. For the right hand side is easy work, man. Very easy work. You know what I'm saying? So when you differentiate dv, you get v. When you integrate this side, you differentiate this side, and then here you integrate. When you integrate dv, you're gonna get v. When you integrate dx, you get x. It's like integrate of d now river soldier, and integrate of dp. When you integrate dn, you get n, and when you integrate dp, you get p. Okay, so that's why I get vx. Okay, so now what is next? Next, we take these values, substitute in here. So we say integral u, we know you could sine inverse of 2x, and dv, we substitute in formula, dv equal to dx equal to, you know what I'm saying? So we have a u. What is a u? Our u equal to sine inverse of 2x times v equal to x. Like this is u and this is v. So sine inverse of 2x times x. But I will encourage you, write x first, and this times that one is the best way of writing. You know what I'm saying? Not saying after, because it's not gonna look good. Okay, so we minus integral. What is our v? Our v equal to x times du. What is our du? 2 times 1 minus 4x. So 2 times, so you say 2 square root of 1 minus 4 x squared dx. You know what I'm saying? But first and foremost, I'm gonna take these 2 behind. You know what I mean? Because this 2 is constant. So I'm trying to save a space, so I'll just write this behind everything. So right behind it, because it's constant. You know what I'm saying? So now you go, you say, oh, excuse me. So now you go, you say then. You know what I'm saying? So I'll take the 2 behind. So this is going to be like x over this. So the problem we have here, everything's fine. But the problem is going to be lying here. So we're going to take this separately and solve it separately. So I'm going to solve this separately. So I'm going to say, let's call this question number 1. So I'll say take this and solve it. So if I take this, means I'm going to take integral of x, 1 minus 4 x squared, and then we got dx. So this is trigonometric by substitution. You know what I'm saying? I can do this by substitution. So I'm gonna do that. I'll let this equal to u, or t, because I already have a u and v. So let's use another letter. You can use k, you can use t. Okay, so let me let t equal to, let's let all of this t equal to this stuff given. Equal to 1 minus 4 x squared. Means I'll take this here. Why do that? Because I know if I'm going to differentiate this, it's going to give me x. And then I'm sorted. So I'm going to say differentiate t is going to give me tt. And then when you differentiate 1, you get 0. When you differentiate this on here, 2 is going to come back, it's going to be 80. So it's going to be negative 80. And then just x. But you differentiate x, so you have to give it respect dx. So I'm looking for this x dx, which is this x dx. So what is x dx? X dx equal to dt over 8. So dt over 80. So let's go next page, you know what I'm saying? dt over 8. Just give me a razor quick. dt over 8. So now I'm gonna make this page just little, you know what I mean? So cool. So now I'm gonna say, okay, so x dx equal to dt over 8. So x dx equal to dt over negative 8, because I'll divide by negative 8 and I'll divide by negative 8. So over negative 8. Oh, okay. So now I'm going to replace x dx with dt over negative 8. So now we're going to substitute in here. So this is going to become, this equation is going to become, let's call this 2. So 2 is going to become equation. 2 becomes, okay, how it's going to become? It's going to become integral. Let's separate here, man. You know what I'm saying? We're trying to separate right here. So we have two spaces, you know. Okay, so it's going to be integral x dx is going to be dt over negative 8. So it's going to be dt over negative 8. And then we have it. There's nothing here. It means you can say 1 in the numerator. At the denominator, we have a square root. Okay, 1 minus 4x squared equal to t. T equal to 1 minus 4x squared. So this is going to be t. Wow. So you see we got two terms here. So negative 8 is going to go to the back. So say, okay, this time we say negative 1 over 8 go to the back, because this is a constant. 1 and negative 8 go to the back. We will be left with the integral. And then here is going to be dt 1 over. So square root of t is like t a half. It's like t a half. So now this integral by power. So I'm going to take power to the top. You know what I'm saying? So this is equal to negative 1 over 80 integral. Take this to the top. It's going to be t negative a half dt. Now we finish everything. So what's going to happen here? We have a negative 1 over 80. So now whenever you have an integral by power, what you do, plus 1 to the top and plus 1 denominator. So I'm going to take my t exactly, take negative a half exactly, plus 1, and everything you did here, say over, do the same thing. Negative 1 plus 1. Now it's finished. You know what I'm saying? So now this equal to, okay, negative 1 over 80. Okay, you have a t, negative a half plus 1 equal to a half. And the same thing, negative a half plus 1 equal to a half here, the denominator. You know what I'm saying? So it's like 8 times a half. This is like 8 over 1. 8 times a half equal to 4. So here you have a negative 1 times t is just negative t a half. But t a half means the square root of t over. Okay, 8 times 1 is 8 divided by 2 equal to 4. But now, the question was not given in terms of t. You know what I'm saying? What's the meaning of t? Our t, it was equal to 1 minus 4x squared. Oh, so I don't need t. It's going to be square root of t, meaning 1 minus 4x squared. 1 minus 4x squared over 4. Wow. So now, when I integrate everything here, means when you integrate all of these, finally is going to give me, so meaning, if I integrate this part here, which is x square root of 1 minus 4x squared, or this one here, dx is gonna give me negative, we got square root of 1 minus 4x squared over 4. Okay, so I'm gonna take this into question 1 main equation because we had a problem here. You know what I'm saying? The problem was here, right here. So I want to take this part here. You know, if you come from that, then you're gonna say take this one here. They substitute the question 1. So I'm gonna say, okay, question 1 is gonna become question 1 becomes okay. So I'm gonna write from here. Question 1 is gonna become, okay. So we're gonna have integral sine inverse of 2x or arc sine, okay, dx. When you integrate, it's going to give you x sine 2x, and they say minus 2, and then multiply by these terms, which we have it already here. Bracket negative, got square root negative 1, oh, 1, just a 1, my apology. It's just a 1 minus 4 x squared, and then bracket, and then we over 4. Okay, so what we do now, 2, this is like 2 over 1. Okay, so 2 by 4, 2 by 4, 1. So it's like everything over 2. You know what I'm saying? So I can just erase these and write only over 2. Because 4 and this is 2, this is 4, so I can just say over 2. So I just want to make it space, so just erase this and I'll say over 2 only. Over 2. You know what I'm saying? Now, negative and negative, positive. So this negative times negative is going to become what? Positive. You know what I'm saying? So I can say negative and negative, positive, so I don't need this also. I can just say what? Positive. You know what I mean? So another thing also, we have our limit. What is a limit? Our limit starts from 1 to 2. So our limit starts from 1 to 2. Means everything's here. It's going to start from 1 to 2. So what I'm going to do, I'm going to take this value here, substituting the whole equation, value of 2, and then substitute the value of 1. So everything's here, means our integral start from 1 to 2, sine inverse of 1 2x equal to, now we substitute the value of 2 everywhere. So we're going to say the face upper limit minus lower limit. What is upper limit? 2 is going to come here, 2. Let's use the pen. So this is going to be 2 here. 2 sine inverse of 2x, sine inverse of 2 times 2, because you substitute upper limit everywhere. 2 times 2 equal to 4, and then plus square root. So we have a 1 minus 2 times 2, 4. 4 times 4, 16. So it's 1 minus 16 equal to negative 17. Negative 17, and then we over 2. You know what I'm saying? So this is upper limit. So we minus lower limit. So we substitute the value of lower limit everywhere. You know what I'm saying? So substitute the value of lower limit everywhere. So you're going to substitute 1 here. Substitute the value of lower limit, which is going to be 1. So if you substitute 1, it's going to be 1. Okay, sine inverse of 2 times 1 equal to 2. Okay, plus square root. Okay, this is going to be 1 minus 4 times 1, 4. So 1 minus 4 equal to negative 3. Negative 3 over 2. So you can plug this in the calculator, but by any means this is going to come as a complex number. You know what I'm saying? Because you know what, I just created this question from head. So just in case if you haven't done yet complex number, you can change the limit. You know what I'm saying? You can change the limit and probably can use other limits or so. You know what I mean? But stuff like that. I could say, let's say 1 to 0. I could say 1 to 0 make more sense. You know what I'm saying? Let's say this is 0. Because otherwise this is going to come as a complex number. So some of the people haven't done complex number yet. Because in a complex number, if you have a negative 17, this same is say square root of negative 1 separately and square root of 17. Okay, Negative 1 is square root equal to I. So this is equal to 17 I or J, whatever you want to use, you know what I'm saying, whatever you want to call it. So for now, some of the people they haven't started yet, so I don't want to go deep into that, you know what I mean? Like this square root of negative 3 means it could be 3 times square root of negative 1. So negative 1 is square root equal to J or I. Just like say square root of 3 times J, because this is equal to I or J. So the base way for now for the people having started complex number, I can change the limit, you know what I'm saying? I can change the limit. Let's change the limit so like it can work it make more sense, because I did this question by creating by my own from the head, so I didn't calculate it. That was what my happened at the end. So let's say upper limit is 0 and lower limit equal to 1. So upper limit here is going to be 0 upper limit. So if it's upper limit here, it's going to be 0 times everything is going to be 0 for the first one. So here it's going to be 0 upper limit. So everything's here is going to be 0 for upper limit. Let's assume something like that. So upper limit here is going to be 0 because 0 times everything is 0 plus. Now 1 minus 4 times 0, 0. So it's just the square root of 1. So here it's going to be square root of 1 over 2. So that's going to make a lot of sense a little bit. Square root of 1 over 2. So it's going to be square root of 1 over 2. So we say, okay. So with plus means with plus. And this going to be 1. 1 minus 4 times 0, 0. So square root of 1 over 2. Okay. Now we go minus lower limit. You know what I mean? So for lower limit equal to 1. So if equal to 1, still it's going to be prime, man. You know what I'm saying? Because if it's 1, it's going to be the same. So we say 1 to 0, right? 1 to 0. 1 is going to give it the same value. You know what I mean? So yeah, but at the end of the day, that's how you solve. You know what I'm saying? But they're going to give it a the right limit to actual limit. I hope you learn from this video. You know what I'm saying? If you identify a mistake, you learn from my mistakes. You learn from my methodology. You know what I'm saying? If there's anything that you think's problem means or I just missed out something, you can leave a comment and tell me your opinion. You know what I'm saying? That's my opinion. That's my methodology. You know what I'm saying? You have learned from it. Look, man, some people say, man, you know, look, my man, I saw you on the TV, man. I saw somebody on TV, you know what I'm saying, rapping music. I was like, man, this guy look like that dude for mathematics. So yeah, it's me, my man. You know what I'm saying? You can also click the link below. You can check out my music, support your boy. You know, give it credits when the credits you leave a comment. Also subscribe to my other channel, man. You know what I'm saying? I just leave the link below. You know what I mean? So thanks a lot for your time and for all your support. Like I say, man, you know my story, man. I was homeless for 3 years and a half. You know what I'm saying? I just beg myself up and do all this. You know. So thanks a lot for your time. I appreciate it. Peace and love.